Hello everyone. So the question today that we are solving is count number of factors of integer n, right? So suppose, let's say if n is given as 10, then how many factors do we have for it? So it will be 1, 2, 5 and 10 itself, right? So total number of factors will be 4. So answer is 4. Now let's take one more example. Let's say if n is equal to 24, then how many factors do we have for it? So 1 is divisible by 24, then 2, 3, 4, then I think 6, 8, and then 12, and then 24. So total 4 these and 4 these. So answer would be 8, right? I hope the question is clear to everyone. So let's see the brute force approach for it, right? So brute force approach for this problem is actually very simple. So what we can do is we can iterate from 1 to n and check if each number is divisible by the given integer n. If each number is divisible by n and increment our answer. So let's write a simple code for it. So the code would be something like this. So for I is equal to 1 to n, right? What we can initialize our answer as 0. So we can simply check if I n% I is equal to 0, then basically we can say answer plus is equal to 1 and we can print answer. So this is the brute force approach. Now here you can see this will take order of n time complexity to complete everything, right? Let's take a deep dive in the time complexity, right? So let's say if our CPU is able to process 10 to the power 8 iterations a second, right? And this is a fairly reasonable estimate that we are taking. So let's say now if you want to calculate the number of factors of a number which is of the power 10 to the power 8, so it will take around 1 second, which is okay. But now let's say now I have to count the number of factors for the number 10 to the power 9, right? So how much amount it will take? It will take around 10 seconds. So you can see this has already crossed DLE for most of the online compilers, right? But now let's just increase this number to the order of 10 to the power 18. Can you guess how much time it will take to count the factors for this number? You will be surprised, it will take around 317 years to calculate this, and certainly we don't want that, right? So our 4th or 5th generation children will get to know what is the count for these factors. So certainly this is not a very good approach to find the number of factors. Now let's see if we can optimize this further. So let's look at some observations, right? Let's try to write down the factors of 24. So if we see 1 is the factor of 24, right? And it gets multiplied with 24, which will give us 24, right? Then we can see 2 is another factor of 24. So it will get multiplied by 12 and it will give you 24, right? So let me just remove this and let's write it down. So now 3 is there. 3 gets multiplied by 8, then 4, which gets multiplied by 6. Now if we proceed further, right, what is the next? So the next is 6, but if we write it down, we see the repetitions, right? Let me just quickly write down others. So then it will be 8 into 3, and then it will be 12 into 2, and then it will be 24 into 1, right? So if we see, these are actually repeating, So the numbers on this side is actually equal to the numbers on this side. Now from this we can pick the observations ki okay, we don't want to go through all the numbers to find the factors. If we found one, we automatically will be able to find the second factor. Agreed? So let's try to apply these observations and let's try to modify our code. Right? So now let's say this is the optimized code. Okay. So what we can do is we can go from I is equal to 1 till our I square is less than m, right? And then we can go I plus plus. Now here what we can do is if n% I is equal to 0, then we can simply increment our answer to 2 because we know there will be a pair which is already present, even though we are not getting to that number, but there will be a pair, and this is it, right? So we have just modified our code, but if you see in this code there will be one problem that you will be facing, right? So what about the perfect square, where let's say for 25 it is 5 into 5, and in this case we will be actually counting it twice, right? So we have to modify it slightly just to handle this case. So let's just modify it. We'll just put a case if I into I is equal to n, right? If I into y is equal to n, then we will simply say answer plus is equal to 1. Else if n% I is equal to 0, then we'll say okay, answer plus is equal to 2. And now we have written the complete code, right? So can you guys tell me what will be the time complexity for this? So the time complexity for this solution is actually order of square root of n, right? Because we are going only till the square root. And now guess what? If I want to calculate for the number of order 10 to the power 18, now guess how much time it will take? It will take only 1 second to do it. And that's how we have optimized our solution. I hope you were able to understand the solution and the optimized approach too. If you want to see more content like this, please do consider subscribing, as I will be posting a different problem every day. Happy coding. Bye bye.